material?
Yes, sir.
You should,
Yes, sir.
guys. And that's fine.
Yes, sir.
See, if you go through that video material, it should be helpful for you. And also try to finish your participation quiz within the due date. So probably your first assignment is coming soon. That is already been ready, because right now they are checking that one. Is there any problem? Because you have to give that input of that answer into the BUX, so that's why they are checking that one, and it should be also the randomized. Probably end of this week or by the Tuesday they will deploy this assignment one. And also you are doing that lab one, right? Are you doing that lab one? Hello, can you hear me, guys?
Yes, sir.
Yes, sir. I haven't started yet, sir.
Why? You should start that one. So
Sir, the values I have those values which I have like some values I couldn't get the straight line. The line is a little bit curvy.
why it should be that one? It should be the straight line.
Sir, that's the thing I can't figure out what's happening.
Did you talk to your lab instructor? Did you?
A few have asked the same question, so I'm just following those answers.
Okay, that's fine. Please follow that one. That's going to be the work for you, I hope. But try to do one that way, actually. So if you cannot understand, you can knock with your lab channel. Right there are lab instructor. They will help you regarding this issue. But keep in touch with them. They will help you, definitely. They're very helpful. All right. So in previous class, I give you a homework on the depending on my problem solving session, actually. Did you do any of you?
Yes, sir.
Yes, sir.
That's fine. That's fine. Okay. Today I'm going to talk about this electrostatic force for three-dimensional case, and also more than one charge particle, actually. This is first problem I choose for two-dimensional case. There is a uneven arrangement of the charge, so that's why I select this problem. It is very interesting. So can you see my screen properly?
Yes, sir.
Yes, sir.
You're fine. It's said that there is an uneven arrangement of the electron and the proton. So is the electron and P stand for the proton on a circular arc of radius r. This is the circular track. You can observe this is the electron, this is the proton, this is the proton, this is electron, and this is also proton. And this uneven arrangement is shown that the angle over here, basically between that the electron 1 and proton, is the theta 1, and theta 1 is basically your 30 degree over here. Theta 2 is the angle between these two protons, or I should label, say, as a charged particle. Say this is actually that this message is giving the message. Let everyone send the message. Can you add me in your private channel of Parvez Mia? Parvez?
Yes, sir.
So did you fill up your Google form, student information form?
Yes, sir. I fill up it in yesterday, sir.
Yesterday. Then you will get the notification. You will find out your
Okay, sir. Thank you, sir.
email. So fine. So now, say they asked me to find out what are the magnitude and direction relative to the positive x-axis. This is your positive x-axis of the net electrostatic force produced on a proton at the center of the arc. So this is actually the center. Say if there is a proton again over here, so there is a proton over here. Keep the proton. Then what would be that net force onto that proton? Say I'm leveling this charged particle. Say that's basically the is for the benefit of the calculation, nothing else over there. You can do in your. So I choose this is a particle 1. Say this is the particle 2. This is the particle 3. This is the particle 4. And say this is the particle 5. And say this is the particle not, or you can say the particle 6. Okay, I am saying this is the particle 6. What I have to do, I have to find out that net force on the particle 6, which is basically the proton, due to other 5 charges at the center. Fine. To find out that one, what we are going to do, we're going to use, say that the net force, we can write, this would be basically the algebraic sum is a 1 to say that 5 into Fi, right? That should be that force. Actually, we are going to add them together, the forces or the vector, right? So that's when I have to add that vector over here. Say first one, if I draw, I'm using say different colors, so then this will be easier for you. Say this one, particle 1, which is electron, and this is a proton. They will attract each other, right? In which direction? Remember, this direction is very important. Since we are going to find out the force on the proton provided by the electron, so electron will give a force on the proton towards itself. Electron will basically attract the proton towards the direction of the electron, right? Since it's the opposite polarity, then I can say this should be, I'm sorry, this should be that force. Say the force on 6 provided by the 1. So this is one vector, right? Second particle is a proton, which is positive, and P is also positive, right? So then they will going to be the repel towards that direction. Then I can say this is the force on 6 provided by the 2. This is the force F2. F3 is also the proton. Then it will give the force towards that direction, right? Although my drawing is not exact, but think about this case basically. It's a free body diagram. So that's mean what are the forces acting on that center of this proton that I'm going to draw over here. So this should be that 3, 6, right? Force on particle 6 due to the particle 3. And particle 4 is again the electron. The electron will attract the proton towards itself. So that's why I can say this should be that force on 6 provided by the 4. And the particle 5 is again is a positive, it's a proton. Then it will repel that particle towards itself. So that's mean this is actually that force on particle 6 provided by the 5. So this is actually the force acting on that center of the particle. If I draw separately, what would be that? You can draw if you want, if it is difficult for you to observe from there, then I can draw, say this is actually that F5 6, right? So this is should be that F1 6. This is should be your F2 6. This is should be your F3 6, and that is supposed to be your F4 6, right? And this is actually your, sorry, this is actually your positive y, and this is actually your positive x. I have to find out the resultant of these forces, 5 forces over here. Fine. So if I want to find out the resultant, so that means I have to find out each of these vector, right? I have to find out each of these forces over here. To find out that one, I'll write down, say, Coulomb's law, which is general format I'm writing, say that force between, say, 1 and 2, I'll write down the Q1, Q2 divided by R12 square into, say, that R12 head from 1 to 2. So if both 2 are positive, they will repel each other, right? So this would be the force on 2 provided by the 1. So that is would be actually that formula over here to find out that forces. Fine. Last one, I know that the magnitude of charges, electron and the proton, are equal. Then I will use the same thing over here. Say first I'm going to find out the force on 6 provided by the 1, which would be K. I use the E because proton and electron are the same magnitude, so that's why E dot E square divided by R square, right? And the R is given. Remember, the R is given over here. R is actually the radius, which is actually that 2 centimeter, right? So distance from here to here actually the 2 centimeter. I'll plug in the value at the end of this problem, so then it will be easier for me to do the calculation. Now this is a vector. I have to give the direction. The direction is going to be basically the positive x direction. So I should write, this would be that force on 1 due to, so sorry, force on 6 due to charge particle 1. Okay, fine. Now what about that second one, force on 6 provided by the 2, right? So this is actually the magnitude K Q square over R square is going to remain same. Now what would be the direction of that one? So I have to find out the unit vector along the direction of that one, right? So towards that direction, because the force is toward that direction, I have to find out a unit vector in the direction of vector 2, 6. Now what would be the unit vector direction? So if I take that component plus that component using the vector triangle law, right? X component negative and y component also the negative, then resultant vector would be that one. I know this angle is 30, theta 1 is basically the 30. Look at this, they give me theta 1 is the 30. Then I can say this angle would be also the 30 over here. Then I can write down that unit vector. Look at this in a form. I can write minus cos theta 1 is a 30 degree. I hit minus sine 30 degree. This is a head, right? I know you can also do by the component method. That will give you the same thing. But I'm doing is a in terms of unit vector. This is very helpful. And it is, once you cope up with that method, it will be very helpful for you. You can find out also the three-dimensional case. Because in the three-dimensional case, it's very difficult to take the component. Up to the two-dimensional case, that's fine. You can find out using that, or you can use that component method. But in the three-dimensional case, it's very difficult. There is a chance to make a mistake. Okay, so this will be my F force on 6 due to the charge particle 2. Do you have any question over here? Any of you? Fine.
Yes, sir. Can you explain about K E square F square?
I didn't get you.
F2
I didn't get you. Could you please
Sir,
repeat it?
can you explain that part K square?
Sorry, there are a lot of noise from your side.
She is asking you that can you explain the KE square?
Oh, that one. That's basically, look at this. This is, we use that formula, that one. So the magnitude K Q1 Q2 divided by R square, right? My charge, look at this. This is the proton, which is, what is that magnitude? Proton is 1.6 into 10 to the power minus 19. And what is the electron charge, which is also the minus 1.6 into 10 to the minus 19 coulomb. The magnitude are equal, right? We can also write down, this is in term of that. I don't use the proton and electron separately. I use the E square. So that's why I write down the E square, because this term is basically the magnitude. It will be remain same for every quantity over here. Only that unit vector would be the different over here. Did you get my point? I write down that only for the calculation purpose. Otherwise, you can put your value. K, P is the charge of the proton, which is 1.6 into 10 to the minus 19, and charge of the electron, which is magnitude of the charge of the electron, which is 1.6 into 10 to the minus 19 also. Instead of plugging that value, I just kept in that way. Is that okay?
Yes, sir.
Fine. Yeah, fine. So let's do for the third one, F36. F36, that I can also write down, say, K E square divided by R square. Now look at this. This 36, right? Now look at this. This angle theta 2, theta 1 is the 30, and theta 2 actually 50 degree. So that's mean this total angle 50 plus 30 is the 80. Then I can say that angle would be also the 80 degree. F36 will also create a 80 degree with that negative x-axis. I can also split that vector in that form. X component and y component is also the negative over here. Then I'll write the same way. What would be that? Minus cos 80 degree. I had minus sine 80 degree j hat. So this is your F36. Fine. What about F46? F46, look at this. This angle theta 3 is 30 degree and theta 4 is the 40 degree. That means this total angle would be that 50 degree. 30 plus 20 is going to be that 50 degree. So that's when F46 create the 50 degree with the negative x-axis. Then I can also split that vector. So x component would be toward that direction and y component would be towards the positive y direction. Fine. Then I can also write down F46. F46 would be K E square divided by R square. The next component is negative minus cos of 50 degree I hat plus sine 50 degree z hat. This is will be that F46. Fine. Now I'm going to write down for F56, which is, where is that my F56? F56 is basically that one. So this angle is create that is 20 degree. Then I can say that angle would be also that 20 degree. So F4 actually, look at this, 20 degree. So then I can write this one would be F56 would be K E square over R square. Now in this case, both component of this F56 will be the positive. This is your will be X component. This is will be actually your Y component. Then I'll write cos 20 degree I hat plus sine 20 degree Z hat. This is will be your F56 component. Now I'm going to add them together to find out that the net force on that particle 6. Fine. Did I find out the 1, 2? No. This is 1, 6. Yeah, I find out that one. Fine. So fine. I'm going to add them all these 5 vector F1, 6, 2, 6, 3, 6, 4, 6, and the 5, 6. Now the resultant force F net is basically, I can factor out this, or I can write one line for you. F16 plus F26 plus F36 plus F46 plus F56. Right. So that's when I'm going to add with I component with I and J component with J. But I cannot add them together, right? I with the J. That cannot be done. But unfortunately, some of you will do that in that exam. So please don't do that one. So I'm doing it in terms of unit vectors in that way so that you cannot do that problem. So most of the case, actually find out the separate X component and separate Y component, and to find out the resultant, you just add them together. You say that that will be the net force. But you cannot do that. X component and Y component cannot be added together unless you express them in terms of unit vector. Okay, fine. Let's do that. Say K E square R square. So if you do that, you will find out. I just factor out that term. Then I'll find out. Say that I component. I just separate it that way. I and J, or I can write down at the time. Say I cos 30 I hat minus sine 30 Z hat. This one actually for 1, 6 and 2, 6 is minus. Look at this. 2, 6 is a minus cos 30 minus sine 30. I write down in that way so that you can understand easily. This will be the cos 80 I hat minus sine 80 Z hat. Then minus cos 50 I hat plus sine 50 Z hat plus cos 20 I hat minus sine 20 Z hat. So this is should be actually that net force. I'm sorry. It's not giving. All right. So now you can find out that forces. So what would be that if you use that formula? Basically, I hope you can do that calculation, right? I'm just giving you that answer because basically you can put that value is K is the 9 into 10 to the 9. charge of the electron 1.6 into 10 to the minus 19, and R is the 2 centimeter. If you plug in that value, you'll find out that your resultant force in that case would be 1.48. I just jump over here. I hope you can do that into 10 to the minus 25 I hat minus 6.10 into 10 to the power minus 25 Z hat. So that should be the resultant force on that center proton. So I hope you can also find out the magnitude and the direction of this vector. You know that how to find out that one. So this is actually the answer of that question. So any question over here? No question. Fine. Let's get into the second question, which is actually that three-dimensional case. Now we are going to dealing with this in 3D. So over here, two charts Q1 and Q2 in the three-dimensional axis. They give you the magnitude of the Q1 actually the 50 microcoulomb and Q2 actually the 10 microcoulomb at location 1, minus 1, 3. Sorry, minus 1, 1, and minus 3, and Q2 actually the 310. M stand for the meter respectively. Find the force on charge Q1 due to Q2. So I position that charge. So this is actually the Q2, which is 3100. So 3, 1, along the Z direction is with the 0. And for the Q2, which is along to the negative X direction, you have to move to the 1. Along the Y direction is a positive 1, and along the Z direction minus 3. So 1, 2, 3. So this is to be that your position vector of the Q1. Now they asked me find out the force on Q1 provided by the Q2. Right, force on Q1 provided by the Q2. So since these two are positive charges, right? So they will repel each other. So that's why that force on that Q2, force on Q1 provided by the Q2 would be toward that direction. So I can write, so this is actually the force on 1 provided by the charge 2. Because they are positive, they will repel each other. So the Q1, Q2 will be give the kick on Q1. So it will move away from the Q2. So that's why that force will be towards that direction, in the direction of vector R. So I find out the position vector R1 for Q1 and R2 for Q2. I can find out that position vector. Say I'm writing, so this is very straightforward. So I can find out, say that R1 position. First, I'll find out this R1 position. I'll find out the force, right? So let me allow to write down the force. So force on, say this is to be the force on 1 provided by the 2. That's going to be the Q1, Q2 divided by R square, or R21, you can say that R21 into R21 hat. This R21 basically indicating from 2 to 1. So that vector is basically, you can write down also R21. This is R21. This will be my formula to find out the force on that one. Fine. Now, first, I know the charges Q1, Q2, Coulomb constant. I have to find out this unit vector, and also the distance between that charge, which will be basically the magnitude of that vector R21, right? If I want to find out the distance between these two charges, which is the magnitude of that vector R21, so that's when I have to find out that R21, and this unit vector R21 would be the vector R21 divided by magnitude of this vector R21. That's we use for the definition of unit vector, vector by vector magnitude. That's mean I somehow I have to find out this vector R21. Okay, to find out that one, say first I'm going to find out, we are going to use that for vector triangle law over here. So first I'm going to find out that R1 vector, which is at a position. I know that position. I'll write down in terms of unit vector I plus j minus 3k, right? This will be that position vector of R1, because this Q1 basically the downward towards the negative z axis, 1 minus 1 1 3. I find out that position vector. What about the R2? R2 would be 3i plus z. Z component is 0, right? Now look at this. This vector R2 here is connected to the tail of this R21. Then the resultant would be basically the R1. So I can draw you for here so that you understand. Say, so this is actually your R2 vector. And this is actually your R21 vector. And this is actually your R1 vector. That's when R2 and R21 are head-to-tail connection. Then the resultant would be R1. So we can write, say, R2 plus R21. That must be that R1, right? Or I can say R21 would be basically R1 minus R2. That I could find out. I know that R1 and R2. In that case, this would be basically that minus 4i minus 3k, because I'm going to subtract from this one to that, minus I minus 3i, that's going to minus 4i, plus j minus j would be 0, minus 3k minus 0. So that should be my this vector. Fine. So this is actually that R21. I find out minus 4i minus 3k. That's fine. So I find out that vector. I can also find out that unit vector divided by this magnitude. What would be the magnitude of this one? R21 magnitude would be 16 plus 9. So that's going to be basically the 25, right? 4 square plus 3 square. So 4 square 16 plus 9. So that's going to be the 25. So the magnitude is going to be the 5. Fine. Now I can find out the force. So to find out that force, what I can write F21 would be Q1 Q2 divided by R21 square into R21 head. Instead of find out that R21, I can also write one more line. Say Q1 Q2 divided by R21 square into, I can write this is R12 divided by R21 magnitude, right? So that's mean we can write this form. So this is Q1 Q2 divided by R21Q into vector R21, right? This R21 square into R21. That's going to be the R cube. Fine. I just now going to plug in this value. What that is a 9 into 10 to the power 9. So Q1 is 50 into 10 to the minus 6 into 10 into 10 to the minus 6. And that distance we find out that 5 cube into that R21, which is minus 4i minus 3k. Now if you solve this on that one, you will find out that force F21 is going to be that minus 0.14 I hit minus 108.108 K head. That should be that force on Q1 provided by that Q2. And you can find out this is actually in the downward direction. So that's why both component, that vector x component is negative toward that direction, and y component is also a negative. Basically, that's going to be that in opposite direction. You can find out. So it's a three-dimensional case. Actually, we can find out in that form. So do you understand that part? Any question over here? Any question over here? No question. So any question over here? So this will be the answer of this one. So try to find out, say, if I say if Q2 is negative, do the same calculation. Do the same calculation if Q2 is negative. Do the practice. That should be your homework, so that you can find out that thing. This one is also the same. Basically, over here, in the different location, actually, we are going to find out that charges. I hope this can also be done. So I'll do it very straightforward. Say, first, I'm going to find out that. Look at this. I can write. So they ask me again, find out the force on Q1 due to the Q2. So now this time Q2 is negative. Q2 is negative. So force on Q1 provided by the Q2. So that force will be toward that direction, right? This is the force. So force on Q1. This is the force on Q1 provided by the Q2. So Q2 will attract that Q1 towards itself. So that's why you can write down this is to be that force on 1 provided by the 2. I have to find out that one. So what I can write, so I can write that force on 1 due to the 2, I can write, say, K Q1 Q2 divided by R square into R, sorry, R head unit vector. Or I can write one more line, simplify, say, Q2 divided by R cube into R vector. Now I have to find out this R1. So R1 is what? I know that 0, 1, 2. So in that case, that R1 would be J plus 2K, J plus 2K, and R2 would be 2I only, right? Because X and Y, Y and Z component is 0. Now look at this. This one, this vector actually R1 and R are head to tail connection. So and this R2 is basically toward that direction. So then I can write from vector triangle law R1 plus R is going to be R2. only the vector triangle log we are using over here. So this is very useful. Then R would be basically R2 minus R1, which would be 2I minus J minus SK, right? This will be that vector R, and the magnitude of this vector, which would be basically that 4 plus 1 plus 4, so 5, 9 is going to be that 3 magnitude. Now you can plug in over there. So if 2, 1 is 9 into 10 to the power 9 into 20 into 10 to the power minus 6. Now it's a minus sign. I have to use that minus polarity sign over here. So 300 into 10 to the power minus 6 divided by 3 cube into that vector R, which is twice I minus J minus 2K. Now you can solve, right, this one, right? If you solve, then you'll find out that force in the three-dimensional case, that force on the three-dimensional case would be minus 4I plus 2J plus 4K. Oh, look at this. This is, I don't have to use the minus sign over here because I already write down that one. Hello, sorry guys. So I have a call from that. So do you have any question over here? Hello, do you have any question over here?
No, sir.
Okay, fine. So that should be your answer basically. For that way you can find out that three-dimensional case. So I don't have to minus sign over here in front of, so I make a mistake. So it doesn't require to use the minus sign. We don't have to use the minus sign because we already find out the direction using that minus sign idea, right? Because look at this. This is actually that negative, so Q2 is negative, so Q2 will attract the Q1 towards itself. So that minus sign giving the direction of that one already, because I write down that vector R is toward that direction. If it is positive, then I'll reverse that direction. So that's why I don't have to use the minus sign. If I don't use, then it should be that minus and minus. That should be the answer of this question. Okay, fine. So this will be your homework actually. I'm going to give you the idea so that you can solve. There are, find the net force, a 20 microcoulomb charge. This is actually that, which is 003 location. And if 4 light charges, also the 20 microcoulomb, are located on the x and y axis at plus minus 4 meter actually. So this Q1 has a, say, that coordinate is say 4, 0, 0. This Q2 has a location 0 plus 4, 0. This Q3 has a location minus 4, 0, 0. And this Q0 has a value, say that 0 minus 4, 0. And this Q4 has a location 0, 0, 3. Then you have to find out the net force on that Q4. All 5 charges actually the 20 microcoulomb. This Q4 is 20 microcoulomb, Q1, sorry, Q0, Q1, Q2, Q3, also that 20 microcoulomb. Then you have to find out the resultant force on Q4 due to other 4 charges. That should be your homework. Do that at home. The same way for that three-dimensional case. Okay, I'm done today. Do you have any more question? So if you have any
Sir,
question, go
স্যার
ahead.
আমি কোঅর্ডিনেটের জন্য হচ্ছে নেগেটিভটা দিচ্ছি না, নেগেটিভ সাইনটা দিচ্ছি না। পরে আমি হচ্ছে যখন এটার শুধু ম্যাগনিটিউড চাবো তখন কি ওটা নেগেটিভ সাইনটা দিতে হবে?
No. Magnitude, so we neglect that plus and minus sign.
মানে আমি বুঝবো কেমনে যেটা ট্র্যাক করতেছে নাকি হচ্ছে দূরে সরাই দিতেছে?
Yeah, that will give you in the question. Look at this. In that question, in that one, we say that the Q1 is plus. For the Q2, we use the minus sign in front of that. Q2 actually 300 microcoulomb.
না স্যার, স্ক্রিন শেয়ার অফ হয়ে গেছে।
Oh, I'm sorry. Can you see it right now?
জি স্যার।
So your Q1 is basically the positive 20 microcoulomb and Q2 is negative 300 microcoulomb.
ওকে স্যার, এটা আমার মেনশন করা লাগবে না, এটা দেখি অ্যাকচুয়ালি বলে দিতে হবে।
Yeah. Plus and minus sign must be the given into the quotient, whether it is a positive or the negative. If they don't use any sign in front of that, then by default it would be positive. Like Q1, right? I didn't use any sign, so that's when it's a positive over here.
ওকে স্যার।
And yes, any more question? Do that. This question is just very useful idea actually. If you can do that one, then the three-dimensional problem will be not a big issue for you. If you can solve this one, if you can understand the previous two problems, then it is easy. It is also easy. You have to use that way always. You are going to find out that vector because you know that vector and that vector. You can find out that distance between these two charges or all these charges. Magnitude will be the same, but the direction will be the different. That's the case over here. The direction case will be over here. Can anyone guess what will be the resultant direction of the force over here? Can anyone guess what will be the resultant direction of the force on that Q4? Just make a guess. If you are wrong, then I will correct you. One guys talk about this vector. It's basically the vector. Vector is necessary. Vector is very important. It should be towards the positive z-axis. You can mathematically find out. Do that to your home. You will find out your answer. Yeah, I'm done with for today. Thank you very much. If you don't have any question, you can leave that live session for.
Assalamualaikum, sir.
Assalam.
Assalamualaikum, sir.
Assalam.